Hello everybody. Give formulas for Bezier curves of degrees 1, 2, and 3 using any of the control points P1, P2, P3, P4. Okay, so part A, I need to give formulas. So a curve is a map. So its formula looks like T goes to, and let's take the Bezier curve of degree 1. And so we only need two of the control points. So let's choose P1 and P2. Okay, so T times P1 plus 1 minus T times P2. Explicitly, I need to show that I know what T1 is. P1 is a vector. 1 minus T is a number, and P2 is a vector. Vector or a point. Okay, so usually a map to R3, so all these control points are in R3, so that means we usually write it as like something, something, something. So let's translate. What is the first coordinate? Well, it's T times 1 plus 1 minus T times 5. T times 1 plus 1 minus T times 5. That is the first coordinate function. What's the second coordinate function? 2t plus 1 minus t times 5. 2t plus 1 minus t times 5. And the last coordinate is t plus 4 times 1 minus t. Or I could have said 1 minus t times 4. Now I'm done with the degree 1 Bezier curve. Part B says for me to draw a cartoon of it. So here's my cartoon. In three-dimensional space, I have P1 and P2. And my Bezier curve looks like this. So this is degree 1 Bezier curve. Okay, let's do a degree 2 Bezier curve. Degree 2, and then we'll do degree 3 and we're done. So this one, the formula will be t squared P1 plus t times 1 minus t P2 plus 1 minus t squared P3, and then I realize, oops, I made a mistake because I need a 2 there. Etc., etc. Okay, so now I have my formula, and since I already showed that I know the P1 and P2 are points in R3, I don't have to do it here. And since I already showed I know how to explicitly write out the 3 coordinates of this map, I don't have to do it here. Okay, so degree 2, this is, and maybe I will say note P1, the PI, note the PI are vectors in 3-dimensional space. Another way to say this is that PI, each of the PI, is in 3-dimensional space. So this is in symbols for what this means in words, and it's important because the other things like 2t times 1 minus t, that's a number. That is a real number. It is not a vector. So this is a vector times a scalar number, and this is a linear combination of vectors. Okay. In fact, it is a convex combination of vectors, but I'll talk about that later. Finally, degree 3. T goes to t to the third P1 plus. Now there's going to be some number from Pascal's triangle times these things, P2. And then there's going to be a t and a 1 minus t to the second P3, and it's going to have some number from Pascal's triangle, and finally, okay. And that is the formula. Okay. So now I just need cartoons. Part B is draw cartoons of each of these three curves. So why don't I draw a cartoon of the degree 2 curve? It involves P1, P2, P3. So I'll draw these 3 points somewhere, and the curve goes something like this. P1, P2, P3. And you see that the curve stays inside the convex hull of these 3 points. The curve goes somewhere in there. Finally, my degree 3 Bezier curve uses 4 points, is P1, P2, P3, P4. So I'll draw those. 2, 3, 4. This is P4, P3, P2, P1. And my cartoon, well, I sort of like to draw just the outline of this convex hull. And then somewhere in there is the Bezier curve flying through that area. And this is it. That's it. I gave the formulas, formula of a Bezier curve of a line, a quadratic degree 2, and a cubic degree 3. And this allows me to do design problems and art with 3-dimensional space, and even higher dimensional space, if I like. Okay. Now I'm going to pause. So this is it. This is your answer. But let me just pause and talk about what parts might be confusing to you. So first of all, how do we know that the Bezier curve stays within the convex hull? How do we know that? Well, let's check that it's a convex combination. So let's look at these numbers. These are numbers in front of our vectors. And let's just add them up. So what do I get? T squared plus 2t 1 minus t plus 1 minus t squared. And what will happen is that these will be adding up to 1, amazingly, no matter what I plug in for t. And that's why we need this 2 there, and that's why we needed Pascal's triangle for the coefficients. Okay, so let's check this. First, what's 1 minus t squared? Well, it's 1 minus 2t plus t squared. This is how I square something that's a plus b or a minus b. FOIL is another word for this. Now here, how do I multiply this? I get a 2t and a minus, this is a minus sign. So I get a 2t and a minus 2t squared. And this has a plus sign, so I'll repeat the plus sign. And then I have a t squared and a plus sign. So let's look at this. Here's a t squared, here's a t squared, and here's minus 2t squareds. They all cancel. This, all cancel. Here I have a 2t and a minus 2t. It cancels. And what is remaining? Exactly 1. And so, why does this Bezier curve stay within that control triangle? Because the coefficients we put in front of it always add up to 1, no matter what t we plug in. Okay? And, and another thing that might confuse you is just what is the formula of a curve? Well, a curve is a map, so you have to say t goes to something, something, something. Or t goes to some expression where you are very aware that P1 and P2 are vectors, so this output is a vector. So it really does map to R3 because P1 and P2 are vectors. In particular, they are this vector and that vector. Okay. And, good. What else could be confusing? Well, okay, we checked that this added up to 1, but how did we know that it was going to add up to 1? So what's Pascal's triangle coming from? A plus b squared. Okay, let's think about that. A plus b squared is a plus b times a plus b, which means I get an a squared, I get a ba, I get a ab, and I get a b squared. And so this is a squared plus 2ab plus b squared. And the coefficients there are the 1, 2, 1 from Pascal's triangle. The same thing will happen if you did a plus b to the third. You would get these coefficients. And now what happens is that if we set b equal to 1 minus a, so think of a as t and 1 minus t, then, what is a plus 1 minus a squared? Well, inside here, this is 1. And what's 1 squared? 1 squared is 1, no matter what a is. And that is why this worked out, because secretly we were taking the number 1 and squaring it. And we wrote the number 1 as 1 minus a plus a, or 1 minus t plus t. Okay, so I just wanted to give some extra explanation of what's going on here. And maybe one more comment. I sometimes see people writing, like, instead of plus signs, they'll write like a dot. But we really need to be aware of what we're adding. And we're adding vectors. These are vectors. Each of these are vectors because each of these is a scalar number times a vector. A scalar number, a real number, times a vector. And so when you write down symbols like P2 and P1, you have to remember what they are. Are they scalars or are they vectors? Right? So that's really important to remember.